change the game. And hopefully then by getting that upfront involvement will increase the kind of conversion rate that happens on the back end when we do eventually get out of the way. Because of course the lab doesn't make anything, we don't sell anything. We're an idea spot. So I think I'm going to start with the third panelist, who I didn't introduce yet, who's Chris Wally. He's the president of Roane State Community College, and actually one of our key partners in an element of what we're doing, which really has to do with the workforce that's going to support some of these advanced technologies. So if you want to kick it off.
Sure. Hello, everyone. Glad to see everyone. Again, I'm Chris Whaley. I serve as the president of Roane State Community College. A little bit about us. There are 13 community colleges in the TBR system. We serve an area, including Knox County. Knox County we serve for allied health sciences, and then 9 other counties that are to the north and to the west of us. Very rural counties for the most part, excluding the work that we do here in Knox County and in Anderson County. We are a little bit unique among community colleges in that we have a very high percentage of our credit, degree, and certificate seeking students who are in workforce preparedness programs. So many community colleges across the state would have a majority of students who are transferred, seeking to take 2 years and then transfer on to a university. A little bit less than a third of our students are doing that. More than 2/3 of our students are looking to get a degree or certificate and then head right into the workplace. We are really excited about the partnerships that we're able to have with the lab and with others. And again, just briefly, we are focused, of course, on the workforce training aspect, part of the partnership. And as we all know, anytime we're talking about growing industry, growing economic development, one of the very first questions is, what type of educational system, what type of K-12, what type of higher education can you bring to the table? And so as we talk about innovative type things that are in the works and on the horizon and are really promising, we need, as higher education, to be on the forefront of being able to provide the credit and non-credit training that goes part and parcel with those types of innovations and those type of industries. It's too late, in other words, for higher education to wait around and see if an industry is going to get started, if an innovation is going to lead to to some type of industry cluster being located in a region. That's too late. We have to partner at the very beginning to make sure that we can supply a prepared workforce and know that ahead of time. And Dr. Apple, my colleague, knows full well that we most of the time are not budgeted for the types of equipment and things that surround those type of innovations. So for us, it's a blessing to get to partner. It gives a lot of weight to grant applications that we are able to put in for, and Roane State's been very successful and blessed to have won several grants in recent years. One that I want to share just briefly with you, just to give you an illustration of what I'm talking about, we call our AMTech grant. That's the Advanced Materials Training and Education Center grant, AMTech. And this is a grant that Roane State was awarded with our partners, about $2.6 million. And this is a 14-week training program, non-credit, for displaced workers, for those who are unemployed, for those who are underemployed, to come in and get some, again, non-credit workforce training in areas such as basic computer skills, lean manufacturing, and then some of the soft skills that are very important, resume writing, how to interview, things of that nature. And we are very excited because among our partners, some of the training for the AMTech 14-week program goes on at one of our TCATs. So we partner with our TCATs to provide part of the training. We partner with Pellissippi State, whose service area we're in here, to provide the forklift training for that program. So it truly is a collaborative process, not only from our partners in being able to get the grant, but also in delivering the education that is part of the grant. So I guess in short, I think with AMTech, whether we're talking about credit training, whether we're talking about non-credit training, I think it has to be the role of the higher education institutions to go out with ORNL to be at the forefront looking at what the economic development demands are, what the industry needs are going to be, and then to be a part of that, to be ahead of the curve with folks like ORNL.
So I work at the lab, so we have to use PowerPoint. This comes with the territory. So it's really, really good to see so many faces from my past, and glad to have all of you here together focused on some of these important issues. I've spent much of my career forming public-private partnerships in the technology-based economic development space, and I can tell you that beyond the shadow of a doubt, there's never been a better time to do that in this region. Primarily because the laboratory has had the opportunity to partner so well with the Rhone states and Pellissippi states and the regional economic development organizations here in the region. We're obviously a huge R&D asset, not just for East Tennessee, but for the entire state. In the past few years, we've been focusing on building some regional industrial clusters around two of our newest facilities. You just toured the manufacturing demonstration facility and seen some of the additive manufacturing capability that is truly going to change the world. We're also building one around carbon fiber composites. So in the western part of Oak Ridge, also off of the central campus, we're building a $35 million facility to prove out our ability to develop lower cost carbon fiber composites. Just a quick word about cluster theory, industry cluster theory. The theory is credited to Dr. Michael Porter from Harvard, and the idea is to develop an interconnected network of private companies and nonprofit organizations, educational institutions, in a particular region to help to develop an indisputable competitive advantage in a particular industry sector. So think about the Silicon Valley, and think about Route 128 in Boston or Research Triangle. We're trying to do that around carbon fiber composites and additive manufacturing, working with our partners. So I've got just a few slides. I was very disciplined. I want to graphically depict this industry cluster for you. So as I said, we start with a really nice facility, $35 million facility down here. We have led the Department of Energy's research efforts in low-cost carbon fiber for more than a decade. And so we have proven at a bench scale that we can reduce the cost of producing carbon fiber nearly 50%. Now, carbon fiber is a fairly small global market, about 100 million pounds today, used mostly in aerospace because it's expensive. It's stronger, it's lighter weight, but it's more expensive and too expensive to be used in mass manufacturing productions, such as in automobiles. But automobiles have huge pressure to become lighter weight, right, to meet CAFE standards. And so as we started building this cluster, we said, let's see if we can build an industry consortium. As Tom said, let's see if we can be proactive and meet with industry and get them to help us understand the challenges that we're facing. In July of 2011, we started a consortium with 14 companies. We now have 55 companies from around the world paying us $10,000 a year, coming here twice a year, learning what we're doing and informing us what we ought to be focusing on. You can't build an industry cluster. You can't have an indisputable competitive advantage without a strong workforce. And we've kind of gotten Chris in a jam a few times because this is a chicken and egg kind of deal, right? So we said, Chris, carbon fiber composites, it's the future. Well, there aren't jobs yet, right? And so we're building a platform. That's what we tell each other. We're building a platform, and it's going to bear fruit. Our regional economic development partner is the Innovation Valley, and Rajan and Tom are both on that board of directors. We're beginning to really see the bear fruit, see some real action here. In fact, we will very shortly be announcing our first major manufacturing location of a company that's coming here specifically because we're developing a cluster in carbon fiber composites. We're doing the same in additive. This is a newer effort. But again, we have an outstanding facility. We've got great staff with wonderful ideas. In the additive space, we're working with a number of very, very large partners, the Boeings, the Lockheed Martins, the General Electrics. The consortium approach we decided to take on this cluster was a local one. So RAMP is a regional advanced manufacturing partnership comprised of about 50 local manufacturers. It's ironic, we spend a lot of time working with Fortune 100 companies around the country. My small staff hosts 100 industry visits a year. But now we're getting to know the Alcoas and the Denzos and the Eagle Bend manufacturers here in the area, and seeing that we can really make a difference to them and to their bottom line. Workforce is going to be important here too. Pell City State is just on the other side of the parkway here, and so Pell City State is our partner in this cluster. They're actually teaching classes in additive manufacturing and teaching classes in our facility. So I see some great possibilities there. We are very active in FIRST Robotics, which is our high school students building robots. The MDF will be transformed. I guess it's being transformed, Tom, right now because the kids are out for the next 6 weeks. Giving them the skills they need. We have a governor's chair that's been hired between the state and the university, a world-leading expert in additive manufacturing who's been a great boost. And you see all along with these partners, the Tech 2020, the University of Tennessee, Pell City State, Roane State, the East Tennessee Economic Council. It really is about public-private partners getting together and having a vision. So real quickly, just a glimpse of what's on the horizon. We're going to do this again in automotive manufacturing, and we're going to try to do it across the state with the Department of Economic and Community Development as our partner. You may not know it. I was surprised. I knew that Tennessee had 3 OEMs. We had Volkswagen, Nissan, and GM. I didn't know that we had 600 companies in the supply chain employing almost 100,000 people. So Tennessee, you see those dots on the map, is really, really a strong manufacturing state, especially in automotive. The Brookings Institute came here over the past year and did a very detailed study on Tennessee's automotive sector. They called it DRIVE. Recommended that we do 3 things: that we work on workforce development, that we work on developing the supply chain, and that we work on innovation and giving our automotive manufacturers access to places like the Oak Ridge National Laboratory. So you'll be seeing and hearing and reading over the next year several things about an automotive manufacturing partnership that will be statewide, and we look forward to cooperating with some of you to make that happen.
Spot. So the final person I thought it'd be nice to hear from is one of our own, since we've been interacting now for I guess a couple of years, and so maybe you could say a little bit about what's going on.
Yeah. All of this is kind of high-level stuff, which is where everything originates. My companies and the things that I do, we're a trailing consumer. We've talked about the leading consumers. And my first interaction came when Tom Ballard kind of had what Tom's job is now. And what I would ask you to leave here with today, which I preach
loud, because a lot of folks don't know it. If you have an idea, if you have a want, if you have a need, if you have a theory, talk to Tom. People don't realize that you can do that. I didn't realize that you could do that. I don't know how I became aware, but someone, I guess 5 years ago, made me aware. So I went out to the lab, and I sat down with Tom Ballard and somebody else, and I explained to him I thought about carbon fiber. Because in my industry, the bulk of what we do is aluminum trussing support. And truss is what you see when you drive down the freeway holding up the green signs. You know, that structure that holds up the green freeway signs is a really big truss. We use sort of smaller versions, but it's expensive, it's heavy, and it's big. So we came and met with Tom and said, we think we can do this out of carbon fiber to help us. Tom said, come back in a week. So I came back in a week, and there were 14 people sitting around the table in the boardroom over at the lab, 12 of which were PhDs. And my first comment was, who's paying for this? And Tom said, no, it's what we do. So we went through a series of meetings and discussions, and we ended up tied together with some lab people and some other private sector people. So we began down this road. And we ended up with a solution where we were going to manufacture all of this structure that my industry needs as a whole. And again, we're a trailing consumer, not a leading consumer. And this was in 07. Well, you know what happened in 08. Well, the carbon fiber business was tiny in '07, and then when '08 came, it even got tinier. Because carbon fiber is, again, a chicken or an egg thing. When it gets cheap enough, everybody's gonna use it, but everybody's not gonna use it until it gets cheap enough. And as I was told in the past, the leading consumer ultimately will be the aerospace industry, with automotive second. I believe that's what I was told. But until such time as it gets cheap enough, neither of them can buy in wholesale. So right now, there are drive shafts being made of carbon fiber, and front walls of trucks being made of carbon, and race cars being made of carbon, and fishing rods, and boat handle motors, and all kinds of neat things that can be made in small scale. But what I need couldn't be done until they got the price down under about $1.50. And the price shot up. There's a company in Rockwood called Toho 10X that we met with, who are going to be a partner, and a company in Cincinnati called DCS who are going to be a partner. And they've both been decimated by the lack of demand, by the economic downturn, and by the fact that there is a tariff on the importation of the raw product. And for those of you that don't know what carbon fiber is, does everybody know what baling twine is? Imagine big giant rolls of baling twine, they superheat it. And what you're doing is you're burning off everything in baling twine that isn't carbon. So they burn it once and it becomes Kevlar, which is what bulletproof vests are made of. They burn it the second time and it becomes pretty much pure carbon. Then you take the raw fiber and do with it what it is that you need done. What am I doing now? We're sitting waiting, because the chicken or egg thing, until such time as demand gets big enough for my industry to be able to afford it, there's not a lot we can do. Now, having said that, the additive manufacturing is interesting, because potentially in my industry we could build these structures out of that. But having said it, we need the big stuff, and you saw there's no machine big enough to build the big stuff. So we're kind of in a waiting game, and the point of all this isn't what I'm doing with it. The point of it is that it's here and it's available. And that's what these folks do, and most people don't know it. We have a second endeavor that we're involved with the lab. It came off the first endeavor, which is LED technology. And the lab developed this stuff called graphite foam. And you put the graphite foam, it's a superconductor, on about anything, and it takes heat or cold to or away from whatever it is you got. Well, I'm in partnership with a company called LED North America, and we put the graphite foam on the back of LED lights, and it super cools them. We started last week, I don't know if Tom even knows this, but we got our first contract in December, and we're installing this brand new technology featuring ORNL LED graphite foam lights for the basketball court in Thompson Bowling Arena. Behind that, we have 2 other arenas lined up to do, and once we get, and we call all 3 of these arenas proof of concept. Once we get through the 3rd arena and everybody's happy, we literally have a contract on our desk for 280 more arenas. And behind that, in America, that we know of, there's about another 300 to 3,500 arenas, and we're already getting letters from people that want it. None of that would be possible without the graphite foam technology from the lab, and that is a licensing deal that they both referred to, where they invented it, they hold the rights to it. 2 people manufacture the product, we indeed buy the product from one of the 2 manufacturers, put it on the LED lights, and go sell the lights. We know that the lights that we're going to put into these arenas are a game changer, because when you go watch the Vols play basketball, each one of those lights weighs about 300 pounds and consumes about 35 amps of electricity. The electric bill at Thompson Bowling Arena is about $40,000 a month. When we put these LED lights in Thompson Bowling, their electric bill is going to drop to about $4,000 a month. So they're going to save $36,000 a month on their electric bill. Because of this foam, these LED lights, we will all be dead before they burn out. So when we're selling them the lights, we tell them that these lights will have a 75 to 100-year life, but none of us will be alive to replace them.
Does the lab profit?
The lab sells the foam.
Yeah, we have a licensing agreement with a company, and
That
so
makes the foam.
we get a licensing fee based on sales. Now, we're not getting rich off licensing fees. Right now, we make about $2.5 million a year or something like that. So our motivation is not that somehow we're going to pay for the lab from our licensing revenue. Our motivation is, we're an energy lab. If every arena in the U.S. drops their electricity consumption from $40,000 a month to $4,000 a month, there's a huge energy benefit to that. There's a huge sort of opportunity cost where because that money's not going into electricity bills, it goes into other things, and that's the real drivers to get the technology out.
And we, at our partnership, we're starting out lighting basketball arenas. We're going to go from that to football stadiums, then we're going to go from that to these things, troppers and downlights and other kinds of things in that space. And again, to Tom's point, the energy savings is the real trick here because the whole country gains from it, because these stadium lights, we're putting 110 of them into Thompson Bowling Arena. You can run 110 of them off 4 wall plugs. I mean, that's nothing. Right now, you couldn't run one of the old ones off of 1 wall plug, to put it in terms that you would understand. And indeed, they produce no heat. So your need for HVAC is zero. These are air conditioning neutral fixtures. You put them in the building and they don't produce heat. And it's a win-win for whoever buys them. It's a win for the country. Again, it frees up capital to do other things. And the LED technology within 10 years will be the only technology. But again, this graphite foam on the back, which the lab owns, is the super cooler to it. And then we also developed an entire range of LED fixtures that are proprietary to my company prior to this sports lighter thing that have nothing to do with the graphite, but had everything to do with advice that we got from the people at the lab. So point in all of my rambling is I've got 3 major projects going on that live and breathe because of what Oak Ridge National Labs does. We reckon that the sports lighter thing will be, the typical job's $500,000-ish. And we know of 4,000 arenas in America, so you can scale it, and then there's arenas outside of America. So we reckon it's probably a $1.5 billion business that we're staring down the face off. So we're excited about that. But the point of all this is, remember to talk about it. If you've got some idea, if you've got some thought, these folks will meet with you, talk about it, and it can be in a great number of areas. And that's really what I wanted to speak to, was this phenomenal resource that most people don't even know about and understand.
So Mike, you just, this is the second time you said most people don't know about it or understand it. So how do you all get the word out about what you do?
Well, you're all here, so you know, you tell 2 friends, and they'll tell 2 friends. That's why we have a partnerships organization, so that they can go out and knock on doors. We're working, you know, we tried to work very closely with Innovation Valley, as mentioned, you know, the Regional Economic Development Agency. We have an increasing interaction with state government through ECD. It began with the Bredesen administration, and it's grown even stronger now with Governor Haslam. So we have very good relationships at a working level with ECD. We're even sharing with UT in some of the salary for Jill Van Beek, who's kind of assigned to this region for the state. And this automotive manufacturing thing that you heard about is probably going to take that interaction to the next level. You know, Brookings threw out some kind of interesting ideas. One of them was that their state should set up a voucher program to allow industry that they may be seeking to recruit to the state access to the lab. And this has been done in other jurisdictions. It's been done in the Netherlands and in Australia, so there are some examples. So to give you kind of a thought experiment of what this might look like, I'm sure some of you have heard about Hankook Tire, which is a big win for Mayor Kim, right? As the Koreans like to call her. You know, one of the things that the state talked about, and in fact I remember we had a chance to talk with Hankook Tire when they were coming in, was that there's a great success story that one of our sister institutions, Sandia National Lab, has working with Goodyear, using supercomputers to design the next generation of tires for Goodyear. In fact, it was instrumental in kind of turning around their prospects at a time when they were really struggling. So they could use computational fluid dynamics on a supercomputer to do a lot of the kind of stuff that you previously had to do by trial and error testing. So now it's tough to test the tires, but they can throw away the 9 bad ideas and really focus on the things that they know work from the modeling and simulation. So that's something that's been proven to work for that industry sector. Hankook also has a lot of interest in polymers, and we have a lot of polymers in the lab. So in the future, when the state is trying to recruit a Hankook tire, it may be that the offer looks a little bit different. You probably know all the details of what they were offered, but there was a piece of land. They had to move some of the electrical distribution system around. There was probably some road access. There's a training program with the community college. Could be that, page 8 of that is access to Oak Ridge National Lab because you want polymer science and supercomputers. And that would be a real differentiator for the state, particularly in our region. You can't do that in Georgia. There's no Oak Ridge National Lab in Georgia. There's not one in North Carolina. There isn't one in Arkansas. And so it would be an interesting way to kind of help get the word out, address the fact that nobody knows about it, because it would be a way that the ECD folks whose job it is to go and market the state, and also for existing industry, when they recognize that there's a problem and they have a company that's struggling and thinking about, are we going to move, are we going to close, can we be competitive? Well, maybe there's a way the lab can help. And the nice thing about the state wrinkle on it is, as a national lab, we can't favor Tennessee companies. We can't take federal dollars and preferentially give them to Tennessee companies. The state of Tennessee can favor Tennessee companies. That's their job. And so we can work with the state in a way that we couldn't if we were just doing it by ourselves. I mean, first thing that would happen is, the senator from Massachusetts would be on the phone with the Secretary of Energy saying, what are you doing, pulling jobs away from my state with your lab in Oak Ridge? Well, if it's the state that's doing it, then who are they going to call? Are they going to call Governor Haslam and complain? So I think there's a real interesting potential there, and that was one of the things that came out of the Brookings study, that we're really interested in exploring ways we can do that, to get the word out, and also give a mechanism, because I don't know, you may have some thoughts on this, but one of the things that I hear a lot is, we're a big federal institution. It's kind of difficult to deal with. I mean, we're complicated. You've got to really have some persistence to make it work, because of, there's all kinds of taxpayer dollars. We've got to be good stewards of those dollars, and that tends to mean there's a fairly complicated rule set around, there's an acronym book we have to give everyone. And if there was some easier mechanism like this voucher program where we could maybe work a bunch of that out in advance, it would help as well.
I want to add one thing to give you clarity, Rachel. The Fortune 500, the Fortune 1000, the big guys all know.
Yeah.
I need to put that into the people that need to know, and they're here in mass. What I meant was little guys like me and most of us think that it's just for the big guys, and it isn't. But to the different level of difficulty, I've had absolutely none whatsoever. Now, I haven't penetrated into that point where we're in each other's pockets and those rules come into play, but the flow of information has been free, forthwith. It's just been stunningly easy. And Tom was remiss in talking about the lab. There are more PhDs in Oak Ridge, in Oak Ridge National Lab than anywhere in the world. And under Tom's leadership 4 or 5 years ago, Livermore National Lab was always the preeminent lab within the scientific world, and we surpassed it. And now most people consider this the best lab in the world, and he's too humble to not mention that, but this is the place where it all happens. And again, in academia and in business, folks that live around this area just don't realize what a phenomenal resource it is.
Not everybody's going to get to go this afternoon, and unless you all talked about it on the bus, this is kind of the first shot for the folks in the Central Time Zone to know about Oak Ridge. And the Secret City has become something very different now. The secrecy is still a question. Could you do a 25-word, what's Oak Ridge all about now? Not just the lab, but what's it all about?
Yeah, so as you said, it was the secret city, so we came into existence as part of the Manhattan Project. And of course, the role that Los Alamos played in the Manhattan Project is well known. You've probably seen, if you saw the movie Fat Man and Little Boy and this sort of thing. And Los Alamos was actually where a lot of the physics was done, but if you look at where the money was actually spent, it was 60% of the dollars were spent in Oak Ridge, and that's because Oak Ridge was a major component of the industrial complex that supported the design effort that was done at Los Alamos. And the reason Oak Ridge was selected, there's a couple versions of the story. Senator Alexander will tell the version that I think that Senator McKellar was the chair of the Appropriations Committee in the Senate at that time, and the president came to him and said, I need your help. We have something that could ultimately win the war. It's very, very secret, and I need to hide $2 billion in the budget. And Senator McKellar said, that's fine. I absolutely want to help you with the war effort. Where in Tennessee were you planning to hide the $2 billion? So that's and I think Howard Baker used to tell that story. So it's been handed down, and no doubt there is an element of truth in that, because we all know how those things work. But the other reason that Oak Ridge was selected is because of TVA, actually. Because of the power and the fact that it's reasonably close to Washington. So as they were looking for, the Los Alamos was set up as a research facility to do the design, but they needed a big industrial site with access to water and power. And so we actually found the memo from the Army Corps of Engineers from 1942. They flew down to Knoxville. There was an Army Corps office in Knoxville. It's probably one guy with a phone. And they met with him, and he said, okay, you know, they had a list of specifications. We need this much flow of cooling water, so many megawatts electricity, can't tell you what it's for. So he looked at it and said, well, we need to talk to TVA. So they arranged a long-distance phone call to Nashville for the following day. You know, you had to book it in advance. Called up the TVA person. The TVA person said, you can't have any power. All our power is devoted to the war effort, to the Alcoa plant for aircraft aluminum. Top priority for the Department of War. And they said, no, you don't understand. We have a letter from the president. We trump the Alcoa. And so after, you know, they had a discussion and TVA came to understand what the pecking order was on priority, they said you should look for sites that were within about 5 miles of the high voltage line between Norris Dam and Watts Bar Dam. Because if you go there, you get a redundant feed. And you know, as long as you're within 5 miles of that line, it won't be too hard to get you the power. But don't go too close to the dams, because we don't know what you're building, but we think it's probably dangerous. So if you look at that geography, they looked at a bunch of sites, and there was one that was a little closer to Knoxville. They were kind of nervous about that. There was another one in Harriman where it was on the main channel of the Tennessee River, so it was probably better for cooling water, but it was a little bit more remote. So Oak Ridge was kind of a compromise. And there were 3 sites, X10, Y12, and K25. K25 and Y12 are production facilities for uranium enrichment. X10 was an R&D facility. So the lab got its start as X10. It was the R&D facility for a industrial scale manufacturing enterprise, which happened to be uranium enrichment. So our DNA has always been kind of adjacent to, you know, manufacturing and scale up. We're a little bit more of an engineering lab than, say, a Los Alamos or an Argonne. We still do a lot of great fundamental science, physics, chemistry, biology, and so on, but it's in an environment where we're kind of thinking about application. So today, the K25 site is being decommissioned and demolished. In fact, before Christmas, they tore down the K25 building, which was the largest building under one roof at the time it was built in 1943. And that's being turned into a large brownfield industrial site. Still a bit more work to do, but eventually, probably by 2020 sometime, there's going to be a, you know, pretty close to a mega site available for development there.
With an airport?
Maybe with an airport, we're working on that. Not a commercial, not a you know, commercial airport, but a small plane airport. The Y12 facility is still part of the weapons production complex. In fact, they're working on a modernization because a lot of their facilities go back to the Manhattan era. And then what was X10 became ORNL in 1946. Actually, initially it was called Clinton Labs. It became ORNL in 1948, actually. And we're an R&D facility. So we're no longer in the nuclear weapons business, really haven't been since the 40s, but we initially focused on nuclear energy and isotopes, and then in the 50s we added fusion. In the 60s we began working on non-nuclear energy and environment. And then in the 70s with the Arab oil embargo, that's when we added in things like the energy efficiency, the vehicle technology. That was all part of the national response to the 1974 shock to the system that eventually led to the creation of the Department of Energy at the end of the 70s. And so since then, we've had this portfolio that's got these three legs: fundamental science, energy technology, global security. And that's what we do today. Any questions?
Tom left off,
Actually,
Tom left off one more thing about why it's in Oak Ridge. It's between two mountains, and if it blows up, minimum collateral damage.
Yeah, right.
I got that from my dad who worked here.
Yeah,
so-
the three sites are in different valleys, so that was sort of a security, safety kind of thing. So they didn't want to take, if one of them went, the others would survive.
Steve?
You know, the focus about.
It's a plot, it's a plot.
The focus is on the Innovation Valley. Obviously, sitting over in West Tennessee, I can't help but wonder, how do we take some of the advanced manufacturing that you're talking about and apply it to, I've got a big shipper over there that's very interested in small parts manufacturing, cutting SKUs out and as part of our ecosystem. How do you see that apply? How do we work together from entrepreneurship, small manufacturer, and obviously a shipper like a FedEx?
Yeah, actually, Fred Smith was here a couple months ago, and we went through the carbon fiber facility and the additive manufacturing, and since then, you know, that spawned a set of activities. I don't know that any of them have yet come to fruition. It was a great example of why we need to interact with industry, because we were thinking that for FedEx, one of the big wins of carbon fiber could be getting weight out of the trailer on an 18-wheeler truck. And there's a small company that we've been working with called Carbon Fiber Composites. Composite Applications Group from Chattanooga that's been working on that, getting weight out of the trailer. Because if you take weight out of the trailer, then that can turn into payload. So you win not only fuel economy, but you also win driver time and capital investment. So we thought this was the big thing for FedEx, and they were quite interested in it. But the thing they really got interested in is those, you know, in the airplane you have those pallet things that they load onto the plane. And they did a quick calculation on the annual fuel savings in aircraft fuel, aviation fuel.
You mean those big aluminum boxes?
Yeah.
That you put everything into?
Turn those into carbon fiber, and I can't remember the numbers, like $100,000 a plane. So I think that's going to be, that may be the first, and you know, we wouldn't have thought of that. It's not our business, but you know, I think when they look at their budgets for aviation fuel as compared to the trucks, there's just more low-hanging fruit there. So we are very interested in working across the state.
And let's put a delegation. We talked with Billy Stair about this a couple of years ago. Bring a delegation of 8 or 10 companies. Tell us ahead of time what they're interested in. We'll custom make a tour
and we've done that with Chattanooga because we share a congressman with Chattanooga. So Chuck Fleischman, and it was true for his predecessor too, Zach Wamp. You know, most of the voters are in Hamilton County, but most of the headaches are in Oak Ridge when you're a congressman because of all that federal appropriation. So you know, both Zach and now Chuck are very interested in finding ways to connect Chattanooga to Oak Ridge so he can tell his constituents, hey, you know, there's value. You know, I'm not distracted. I'm doing important things we've had a group, you know, in both directions going back and forth trying to identify where are some potential technologies. And we've also been doing things like send some of our scientists down to Chattanooga to the Gig Tank, you know, to pitch some of the technologies to entrepreneurs. And we would be, you know, delighted to do that across the state. You know, go to Nashville, do the same thing. We had a great discussion in Nashville that Senator Frist convened, talking about data analytics and IT for the healthcare industry. because of course Nashville has a prominent place with companies like HCA in healthcare administration, and big data is something that we do, particularly in national security space, data analytics and high performance computing and so on. And so there may be opportunities there. And in fact, we've got a visit in a week or so with MDON, which is one of the companies in Nashville that processes, I think it's something like 60% of the private medical billing flows through MDON, which is an extraordinary rich data set. And if you're looking at reducing the cost of healthcare and getting greater efficiency out of the system, if you could actually use that data in an intelligent way, it could give you a real competitive advantage. So, you know, there's an example with Nashville. So if any, you know,
Mayor, we're working on a road show. We're bringing Oak Ridge to Nashville this spring. I was on the phone with Michael Burcham and one of the Tennessee guys last week. Okay, so.
I'd like to vote that you consider that thought process. You know, I know Memphis is a little further away, but the logistics area, the logistics ecosystem, and the opportunity for entrepreneurship and logistics, which is really what we're taking on there, is clearly an area where there's lots of opportunities here. It strikes me that we ought to be thinking there too. Tell me what we need to do.
Okay.
Give you an idea of the gravity. We sell FedEx 1 million gallons of jet fuel a day, which is 90% of all the jet fuel used in the state of Tennessee.
wow.
Every day, 1 million gallons.
There any report says 1.
So you make a 1% dent in that, and that's a
Yeah,
big
you put-
number.
Yeah.
2% dent is a really big
Yeah,
number.
really big.
Yeah, their annual report says they use 1.3 billion gallons of jet fuel annually.
Yeah.
500 million gallons of diesel, 1.3 billion gallons of jet fuel.
Yeah.
Big number.
Yeah, well, we would love to connect, and it, as Tom said, if we could get, you know, a little bit of back and forth traffic with some definition around what topics you're interested in, that's very helpful, because there's a lot of cool stuff to see at the lab, but for a particular group, only a subset of it is going to be really important.
We don't want you driving 6 hours for an overview, right?
Yeah.
So let's spend enough time to work on what it is that we're really gonna see, and if we have to divide them up into 5 different, you know, groups, we'll do that.
And that goes back to my original experience.
Yeah.
Not the first meeting, but the second one. They walked me through the carbon fiber lab at the time.
Right.
And I saw other things that were going on. They said, now we're doing this with it. I mean, and the ideas just begin to come. So Steve, you really got to get your folks up here. And then the ideas just, you see it and go, well, I never knew that.
Question.
Yeah. Yeah.
Obviously not.
Well, Tom may not want me to speak because interestingly, I loved this talk. It was really interesting and neat, cool stuff. And I feel like I'm listening to this and I'm seeing the very best of our government and absolutely the worst, most inefficiency as well. You're doing fabulous work. You're creating new technologies and really a new world, a new way of doing all these things, and you're letting everyone else profit off of it. I mean, the idea to me that you are only getting a licensing fee, when clearly you should, at a minimum, be getting 15 to 17. Mike said just on this LED project, he's anticipating about $1 billion. And what are you guys gonna get, $100,000 in licensing fee?
It'd probably be more than, on $1 billion, we'll get more than 100,000, but, you know.
Well, is your percentage any worth it? Because I thought you
Yeah.
said all your licenses.
But remember,
fees
our
combined
technology
were
is only a
$2.5
little
million.
piece of this. This is the tricky thing, is that.
Cree's involved with it.
Yeah, Cree's got the LEDs, and so everyone's got a little piece. But, yeah, it's an interesting challenge. I mean, where we tend to be involved is very early. So when venture capitalists come to the lab and look at what we're doing, you know, their initial response tends to be, that's really, really cool, but it's really early. It's extraordinary. It's not even clear what industry sector is going to benefit. And so it's very hard for the private sector to, you know, go to their shareholders and say, you know, we need to make an investment in this because this new technology is going to transform someone else's industry. And so that's why, you know, there's a federal role in the component of what we're doing, because it tends to be, you know, way pre-competitive. So the challenge is, how do we take all these great ideas that we have, where we're not even sure, what industry sector, let alone what company, and move them along far enough that then the private sector can come in and say, yeah, I need to invest. And that's sort of the tricky dance that we have to manage. Now, as it gets closer, often there will be kind of co-investment. So we don't take it all the way to the point of, a working product on federal dollars. So it'll start out in the science domain, it's kind of 100% federal. A lot of the joint programs we do in the applied technology are kind of cost share, and then obviously with the licensing, then there's some flow back. But I tend to feel like the lab, our weight needs to be in the areas where the private sector will not be able to act. That's where it's clear that we have a role. And once the economics start to become really compelling, the argument for us to be involved gets a whole lot weaker. And so it's just a matter of having that handoff. And that's where we're kind of focused in. How do we hand off? Because as you know, the examples where the public sector has got heavily engaged in things where the market can do it are not great examples often, because in some level you really do need to let the economics drive things once you reach that point that you can do the math. And there may be particular reasons. I mean, defense is one where it's a little bit different, because if the end-use customer is the Army, clearly the government's got an interest and can push it right along to a finished product. But in the energy space, the energy sector is not in public hands by and large. It's the automotive. Most of the utilities, TVA is kind of an exception. Most electrical utilities are private. All the vendors, the Westinghouses and GEs and so on. The energy business in the U.S., not true in all countries, but in the U.S. it's a private sector activity. So we got to be able to hand off and get out of the way at some point. And so then it becomes a question of, at that point of interface, what's the rules of engagement in terms of who pays?
You want to take the last question, then we'll get
Oak Ridge is known as the world's, best place for materials science research. And because you came here building the spallation neutron source, and currently you're a partner with UT on the Joint Institute of Advanced Materials that's going to Cherokee Farm, I just wanted you to comment on what that looks like at Oak Ridge and what you're involved in. I know carbon fiber came out of that, et cetera, but just expand on that.
Well, kind of the cartoon version of it is that you make things out of stuff, and we worry about the stuff. And it sort of sounds a little bit trite, but the fact that we're starting to see more of an interest in manufacturing in the U.S., I think we kind of got into a mode for a little bit where we thought, maybe it can all be a virtual world and we'll all do software development, and that's sort of nice from an investment point of view, because you don't have the scale of Facebook got to its capitalization with 20,000 employees and almost no capital investment. So for certain, from an investor point of view, that kind of virtual world looks kind of attractive. But I think the thing that people have come to realize, really rediscover in the last 5 years or so, is that if you don't have some people who are actually making things, you don't have a real economy. Personally, I don't think it's viable to have a world where our economic model is, you cut my hair, I'll shine your shoes, and somebody else will wash your car. That's moving money around. And where you actually create wealth is where you make something. And when you make things, which is really what manufacturing is, part of your edge has to be, the manufacturing processes and materials you use. What's the raw material cost? What's the energy cost to convert it into a usable form? And what are the performance characteristics? And there's really tremendous leverage from using some of these great science tools we have, like the neutron source and the supercomputers, where we can understand materials, to actually design their performance characteristics in a way that gives you a better product. It's lighter, it's stronger, it's cheaper, it uses less energy, it's prettier, whatever the performance spec is on the back end. And you know, if you pull out your smartphone and you say, what's the innovation in here? Well, part of the innovation is the idea and the user interface, no question. But it's made possible by the fact that you've got, you know, flash memory in there where you can store every song you ever listened to, and you've got this amazing screen that you can kind of touch and see, and it's got little LEDs that display color, and there's a battery that will, you know, if you don't web surf too much, make it through the day. And all of that is materials innovation. And you're seeing the same thing in the automotive sector, driven by policy with the fuel efficiency standards. There's more innovation happening in the automotive sector now than has happened since Henry Ford. You know, we went through this very fertile period around the turn of the last century where people weren't even sure, is it going to be gasoline? Ford invested heavily in ethanol plants. You had steam-driven vehicles. There was all kinds of people trying out different ideas, and we discovered that, you know, in Pennsylvania, this stuff bubbled up out of the ground that you just had to go and collect, and it made for a good internal combustion engine, and then we innovated on cup holders for many decades. Well, that's now changing, and you're seeing a lot of experiments. You know, you got some automotive manufacturers that are pushing hard on diesel, right? The German companies in particular, VW Group, is pushing hard on diesel, BMW, so on. You've got some that are doing the hybrids, Ford, Toyota, pushing really hard on hybrids. You've got Nissan that went all the way to pure electric vehicle. It's not clear, I would say, what the mix is going to be coming out on the back end. But all of them are pushing really hard on lightweighting, because no matter what your drive technology is, you use less energy if the vehicle is lighter. And so there's a lot of materials innovation that's kind of under the hood in the automotive sector, and it's a really interesting time. I mean, I think 10 years from now, we may know how that settles out, but right now there's some very big bets being placed. And obviously, since that's such an important sector for the state of Tennessee, we want to make sure that as you disrupt the supply chains, you know, we're seeing investments already. Alcoa, for example, is investing $250 million in standing up a new aluminum capability because the F-150 truck is going aluminum. And that's a great benefit for Tennessee that we were well positioned for because of the Alcoa plant. And we want to be well positioned if carbon fiber takes off. That's going to disrupt the supply chain. There's a set of people tooled up to make steel parts, and someone else could be making the carbon fiber parts. And so we want to make sure that we're kind of on the front end of that, not on the back end, you know, trying to hang on to the old technology. And we better start moving to lunch. There's food I'm behind, and there's nothing scheduled for the next little while, so we can kind of eat and continue the conversation.